Hello, Elias Campos here. Full disclosure, I am a full-time employee of Horton Automatics, the owner of this simulation and this tool. Today, I want to talk to you about an energy simulation that we developed a few years ago to account for the energy savings, equipment savings, CO2 savings, and payback analysis of using uh, a revolving door as opposed to using a sliding and swing systems. What you see here on this simulation on the left hand side, you have the project characteristics, and that includes the project location, uh, the height of the building, the usage and people per day that will come into the building, the hours of operations of the building, the desired indoor humidity and temperature, as well as the cost of your electricity or heating in your location and the wind speed. This drop down menu here for the project location holds the environmental weather information for most major North American cities. In this particular case, we have selected Chicago, Illinois, but we may as well select Indianapolis, Indiana. And the simulation in the background will pull the proper information and make the corresponding analysis and simulation. On the right hand side, you have the two alternatives. You have either the traditional swing and slide entrance, and it requires to enter the cost of those entrances, as well as the sum of the opening width and the height of the building. The height, not of the building, rather the height of the opening. And in this case, we have selected a door that is 7 feet and 8 inches tall and has a sum width of 8.1 feet. And as an alternative, we're selecting a revolving door. It's a three-wing revolving door whose cost is about, say, $80,000. The height of the door is similar to the height of the swing system. Let's set it up as 775. And the diameter, since this is an automatic door, and let's say that is a 10 feet diameter door, which is the minimum here to comply with the ANSI requirements. And what you see at the lower right is the result of the simulation. In the red bar is the energy usage that will result for having this type of a sliding or swing system. Is about $90,000 a year. In blue, you have the alternative of using a vestibule system. This is a non-vestibule system. This is a vestibule system, and you will have less energy usage, about $30,000 less a year. And in green, you see the result for using a revolving door. So when we do this investment of 80,000 versus this investment of 20,000 result in a payback of either 8 months if you're using a vestibule and you're not using a vestibule, or 13 months if you're using a vestibule, which is probably the more common application, particularly in the areas when you have a significant variation in climate from season to season. So this shows what the payback is, and two important elements here in the simulation is, number one, the CO2 emission savings. We're talking about between 750,000 pounds per year of CO2 savings in the case of a non-vestibule entrance, and about 500,000 pounds of CO2 for this location. And not included in this payback period is also the savings that you will experience by virtue of having a smaller heating and air conditioning system, which is shown as the tons of cooling that you will need, fewer 7,562 fewer tons in this case, and 738,000 BDUs per year in heating costs. So as you can see here, the simulation helps you explain why a revolving door is a better environmental and financial consideration in locations where you have the opportunity to do so. Mentioned here, we can change this to another city. Let's say they go to Chicago and the simulation changes and it shows the result for that city. So I hope this is useful. Please visit horton.com that is horton.com, to connect with us, to find your local RBM or your local distributors and get this tool in your hands, in the hands of your clients.